Okay, boys, it's another day. It's another attempt at trying to make some sense of DC brushed motors current waveforms. So my test subject today is my little 12 volt DC pump. You know, the kind you plug into your cigarette lighter type thing. You pump up your tires if you have a flat. It was very handy back in the day when my boy was on the go-kart track, I can assure you. But those days are done. So now it's a little more than a test subject. So I'm going to turn it on. It has not an issue that's going to stop it from running completely. It remains serviceable, I guess, but it's probably seen better days. It has many cycles. How many hours of operation, I don't know, but there's a lot of cycles on that thing. I used it quite a bit back in the day. So let me, without dragging this out, let me turn it on, and we'll get a look to see what we're considering here. So I just turned it off there, boys, because I froze the waveform because it is a horrendous amount of noise. Unfortunately, I seem to have frozen on a not very good snapshot. So let me run it again. There we go. That's what I was looking for. So what's the story with this motor? I think you can see on the waveform there that we definitely have some weirdness, for lack of a better word, going on. You can see here we have a downward spike towards 0, and that's basically plunging right to 0 amps. So effectively, for moments in time, the little pump is drawing no current, although be it very, very short periods of time. So what does this actually signify? Well, I think it's pretty clear what that signifies. This is a waveform that is a typical scenario where the brush to commutator contact is marginal. We've seen earlier that the waveform didn't suffer from that. So we know that anytime you see, or if you may not know, but if you consider it, if you see 180 degrees of rotation or greater without any repetition of the dropout, you know that it's not an open winding. It can't be an open winding if you see greater than 180 degrees of rotation on the motor. So it's just a momentary loss of contact, let's say between the brushes and its respective commutator segment at that particular moment in time. This condition will only worsen. It's not going to fix itself. Yeah, so this waveform is actually quite erratic. It's actually kind of difficult to tell how many segments it's actually got, but as far as I can tell, it's a 6-segment commutator, I think. If you count there, 1, 2, 3, 4, 5, 6, and then I believe this current hump here is the same as that one. So 6 segments, and then it repeats 1, 2, 3, 4, 5, 6. But again, it's just so erratic that it's quite difficult to tell. Again, this is a different snapshot, but you can see the current is virtually down to nothing right here. That's a sure sign that the commutator and the brushes are of marginal contact. So I hope that makes some sense, boys. Depending on how critical this motor actually was, you'd have to decide for yourself whether it justified replacement or not. If it's the blower motor for your conditioned air in your car, your ventilation system, perhaps it's not that critical. If it's your fuel pump, different story. You'd have to decide for yourself whether it would justify removal from service. Anyway, I hope that made some sense, boys. I think that's a pretty clear, pretty graphic example of a commutator and a brush issue, marginal contact I guess we could call it. So that's it. I will mention, boys, some of you may or may not have noticed that I actually took down part 3 in this series. This is going to be part 4, so part 3 will be missing for the time being. When I watched that in playback, I wasn't really happy with it. I thought there was a few mistakes. It was kind of mixing terminology, and I could have made it clearer. So when it comes to shorted winding on the armature of a DC motor, it's a wee bit difficult to explain and certainly difficult to simulate. So I just got lucky here, and it happens my little pump is questionable integrity. Well, it doesn't surprise me again how much money I paid for it. Maybe I should try and find some cheap gear. It makes for better examples. All right, that's that, boys. Cheers.